3 engines, 1 tower arm, 0 room for error. Ship 41 just got its final Raptor engine installed, and SpaceX is racing toward the most dangerous flight in company history. The first attempt to catch a Starship out of the sky. 7 weeks. That's how long it took Ship 39 and Ship 40 to go from final engine install to launch pad. Ship 41 finished engines this week. Do the math, and Flight 14 could happen before September even begins. But here's the twist. Flight 13's splashdown was so precise, Elon Musk says it would have been caught by the tower arms if they'd been standing there. So why did SpaceX choose the ocean over the tower? And what does that floating ship in the Indian Ocean tell us about what happens next? Every Starship before this one followed the same script. Splash down, tip over, explode, sink. That was the pattern. That was the rule. Ship 40 broke it. 1 week after Flight 13's splashdown in the Indian Ocean, Ship 40 is still floating, on its belly, riding the waves like it has nowhere else to be. SpaceX posted the video themselves. No commentary needed. The image says it all. That single detail matters more than it looks. A rocket the size of a 10-story building is not built to float. It's built to fall, land, and either get caught by a tower or come apart on impact. Ship 40 did neither. It touched down so gently, at such a precise angle, that the ocean simply held it. Think about what that means in numbers. Ship 39 tipped and broke apart shortly after splashdown. Every ship before that did the same. Ship 40 has now been floating for over a week. That's not a small improvement. That's a completely different landing profile. And that's the first clue in a much bigger story. A landing this controlled isn't an accident. It's data. And SpaceX just told us exactly what that data says. On Wednesday, Elon Musk posted 7 words that reshaped the entire Flight 14 conversation. The ship landing was precise, meaning that it would have been caught by the tower arms. Read that again. Not the landing was good, not the landing was survivable. Precise enough to be caught. To understand why that's such a big claim, picture what catching Starship actually requires. The tower's arms, nicknamed Mechazilla, have to grab a booster or ship falling from space within a margin of a few meters. At the speeds and forces involved, a few meters is nothing. It's the rocket equivalent of parking a bus, using only 2 mirrors in the dark, doing 60 miles an hour. Flight 13 hit that window, in the ocean, with no tower there to catch it. That's the paradox, sitting at the center of this entire flight campaign. SpaceX had a ship precise enough to be caught and let it land in the water anyway. Why would they do that? That's likely the reason. Precise enough to catch isn't the same as proven enough to risk a multi-billion-dollar tower on the first attempt. SpaceX doesn't tend to gamble hardware that expensive on a single good landing. Flight 13 reads like the proof of concept. Flight 14 is where they cash it in. The test nobody was talking about. While everyone was watching the landing, SpaceX was running a second experiment. This one had nothing to do with catching anything. It had to do with survival. Musk confirmed that Flight 13 intentionally flew a much higher acceleration profile. Translation: SpaceX pushed the ship harder during ascent than ever before, specifically to find out if the heat shield tiles would stay attached under higher dynamic pressure. Here's the simplest way to picture dynamic pressure. Hold your hand out the window of a moving car at 30 miles an hour. Now do it at 90. The force isn't just bigger, it's a different category of force entirely. That's what Starship's tiles were facing, deliberately, on purpose, at levels beyond anything flown before. The test was successful. The tiles held. Why does that matter beyond bragging rights? A heat shield that survives higher dynamic pressure means SpaceX can fly steeper, faster ascent profiles to carry more payload. More payload means more cargo to orbit per flight. More cargo per flight means fewer flights needed to build out Starlink, refuel a moon lander, or eventually supply a Mars mission. 1 test, 2 outcomes. A ship precise enough to catch, and tiles tough enough to push harder next time. And then came the paperwork. Flight 13 had a rough moment during ascent. The booster experienced an early shutdown during its boost back burn, the maneuver that steers it back toward the launch site. In past campaigns, an anomaly like that has triggered FAA mishap investigations that grounded the next flight for weeks, sometimes months. Not this time. The FAA confirmed no mishap investigation is required for Flight 13. The regulatory path to Flight 14 is completely open. Put those 3 results side by side. A catch-precise landing, a heat shield that survived the hardest ascent ever flown, a clean bill from the regulator. That's not a good week. That's every single obstacle between here and history clearing at once. Which raises the obvious question. If everything's clear, what's actually standing between SpaceX and the first tower catch of a Starship? One thing, a vehicle. Racing the calendar. Ship 41 just received its third and final vacuum Raptor engine. In the coming days, its sea-level engines are expected to go in as well. Once that's done, Ship 41 is engine complete, ready, at least on paper, to begin its test campaign. This is where the story gets tense, because SpaceX's own history gives us a countdown clock. Ship 39 received its engines in early April and launched 7 weeks later, on May 22nd. Ship 40 received its engines on June 5th and launched on July 24th, also close to 7 weeks. But that timeline included a strange single-engine static fire, a rollback to the assembly building, and a launch abort that forced SpaceX to swap out 6 engines before finally flying. Ship 41 finished its engines at the very end of July. 7 weeks from now lands in mid-September. That's the cautious estimate, built from a campaign that hit turbulence. But the math has a twist. Both of SpaceX's previous timelines were dragged out by real delays. If Ship 41's static fire campaign runs clean, with no rollback, no engine swaps, no abort on the pad, late August becomes realistic. That's not a guess pulled from nowhere. That's almost exactly the monthly launch cadence Gwynne Shotwell promised publicly months ago. So the real question isn't when Flight 14 happens. It's whether SpaceX has finally beaten the pattern of delays that's defined every campaign before this one. Ship 41's static fire test, whenever it happens, will answer that question before any press release does. While Ship 41 races toward its engines, a completely different piece of hardware has been rolling around Starbase, and almost nobody could explain what it was for. It's a strange nose cone, reinforced, fitted with an unusual bracket near the tip, a pipe socket, and 6 connection holes that had no obvious purpose. For weeks, the community split into camps. Some thought it was a propellant transfer interface, hardware needed for refueling Starship in orbit, the single technology that makes Mars missions possible. Others guessed it might be a docking adapter tied to NASA's Artemis program. This week, the cone rolled into Megabay 2, and the picture sharpened. Engineers have been seen adding a reaction frame onto the base of the payload dispenser, along with hydraulic hardlines and valve hardware. The leading explanation now points somewhere less exotic, but arguably more important. A structural test article, built to simulate the stress the payload bay experiences during liftoff and maximum aerodynamic pressure. Connect that back to Part 3. Remember the higher acceleration test on Flight 13? If SpaceX wants to keep flying steeper, harder ascent profiles to carry more payload, they need to prove on the ground, safely, without risking a flight vehicle, that the nose and payload structure can physically survive that stress. That's likely what this cone is for. Is that confirmed beyond doubt? Not officially. The 6 connection holes still don't have a stated purpose, so a refueling or docking role for that specific piece of hardware isn't completely ruled out. What's new is this. It isn't a mystery about what SpaceX might build someday. It's a mystery about what they're testing right now, in a building most people never look at. The ship they're sailing out to recover. Let's return to the ocean because there's a detail in this story that deserves more attention than it's getting. SpaceX isn't just watching Ship 40 float. They confirmed they're sending a ship out to physically recover it. Consider what that actually means. If this recovery succeeds, SpaceX gets back the very first Starship that flew to space and survived the journey home. Not telemetry, not sensor logs, the actual vehicle. Every tile that survived re-entry, available for inspection one by one. The engines that performed the landing burn, ready to be pulled apart and studied down to the bolt. That's a category of data no computer readout can replicate. Telemetry tells you what happened. A recovered ship tells you why. Now, before anyone assumes this is legally complicated, it isn't. Ship 40 came down in waters near Australia, and the United States and Australia have a technology safeguards agreement in place since 2023, the same type of treaty that already lets American company Rocket Lab launch from New Zealand soil. It explicitly covers returning U.S. space technology through Australian territory. SpaceX will still need permits, but nothing here stands in the way. So where does Ship 40 actually end up? Nobody's confirmed it yet, but there's a strong theory forming, and it's worth sitting with for a second. Starbase is currently building a new dedicated display area, likely a rocket garden, to replace the old one that lost public access. If Ship 40 ends up standing there, it won't just be a museum piece. It will be the most historically significant flown rocket on public display since the Saturn V, a ship that broke the rules of how Starship landings are supposed to end, sitting there for everyone to see exactly what precise enough to be caught actually looks like up close. Everything so far has been about one flight, one ship, one tower. But there's a much larger claim sitting quietly inside all of this, and it deserves its own spotlight. In a reply to NASA Administrator Jared Isaacman and entrepreneur Peter Diamandis, Musk wrote that people could be on Mars in roughly 5 to 7 years, with an uncrewed lander arriving a few years before that. Translate that into real dates, and you get humans landing on Mars somewhere between 2031 and 2033, with an uncrewed touchdown attempt possibly as early as 2029. Here's where skepticism is earned. In 2016, Musk promised cargo missions to Mars by 2022 and crewed missions by 2024. Neither happened. Mars dates from this company have a track record, and that track record is not clean. So why treat this one any differently? Because the gap between promise and hardware has changed shape. The 2016 promise came from a company that hadn't yet built the rocket meant to make the trip. This one comes from a company that flew that rocket, landed it precisely enough to be caught, is building the next 3 ships in parallel, and just raised $86 billion with a prospectus that explicitly lists Moon and Mars infrastructure as a spending target. That's not proof the timeline holds. Mars transfer windows open roughly every 26 months, and missing one means waiting more than 2 years for the next. And there's one piece of technology this entire plan depends on that hasn't been demonstrated even once: transferring propellant between 2 ships in orbit. Without that, a Starship literally cannot carry enough fuel to reach Mars, land, and come home. So here's the fairest way to frame it. The imagination gap has closed. The execution gap hasn't. Whether 2031 happens depends entirely on whether SpaceX can prove orbital refueling works, on a timeline measured in years, not headlines. 2 companies, 2 very different weeks. Starship isn't flying alone in this story. While SpaceX pushes toward a catch attempt, 2 other players made moves worth understanding because they show how the entire industry is reacting to Starship's shadow. Start with Rocket Lab. The U.S. Space Force just handed them a contract worth up to $266 million for a run of suborbital test launches using a modified rocket called HASTE, short for Hypersonic Accelerator Suborbital Test Electron. 12 flights are locked in already, with an option for 6 more. The reason comes down to geography. Most of those launches will fly from a brand new pad in Kodiak, Alaska, not from Florida or Virginia. Why does that matter? Rockets can only launch out over open, empty ocean, away from populated areas. That single safety rule decides which direction a rocket is allowed to fly, and that direction decides the tilt of its orbital path, what engineers call inclination. Florida and Virginia both face east, perfect for standard orbits, terrible for the steep, pole-facing trajectories that hypersonic weapons testing actually needs. Getting around that normally requires something called a dogleg maneuver, a mid-flight swerve that bends the rocket's path onto the angle a mission needs. Picture merging onto a highway, except there's a wall exactly where the on-ramp should be. You have to brake, swerve around it, then burn extra fuel to get back up to speed. Extra fuel burned mid-flight means less payload capacity delivered. Kodiak eliminates that problem entirely. Sitting at 57 degrees latitude, surrounded by open Pacific water in nearly every direction, it offers the widest range of launch headings of any commercial spaceport in the United States. A full arc from 59 to 110 degrees, with nothing below the flight path but cold ocean. No doglegs required, no wasted fuel, just aim and fly. That's the advantage that made a remote island in Alaska more valuable to the U.S. military than any coastal launch site in the lower 48. Meanwhile, Rocket Lab's larger rocket, Neutron, saw its own development milestone at Wallops Island, Virginia. Crews removed a second-stage static fire test stand from the launch pad in a slow, controlled crane lift. There's no confirmation yet on exactly why, but one strong possibility stands out. This could be preparation to finally mate Neutron's actual second stage to its launch mount, a moment the entire industry has been waiting on. 2 companies, 2 very different weeks. One building toward a historic catch, the other building toward its own first flight. The dishes that almost went silent. Now, for the part of this story that has nothing to do with rockets launching and everything to do with whether anyone can hear them once they're gone. Spain spent the last several weeks fighting some of the worst wildfires in its modern history. 3 heat waves back to back, a national emergency declared, Over 300,000 people evacuated across Spain and France combined. On July 24th, those flames reached the Madrid Deep Space Communications Complex, 65 kilometers west of the capital. That single location matters more than almost any other piece of ground infrastructure on the planet. NASA's Deep Space Network runs on exactly 3 sites, spaced roughly 120 degrees apart around the globe. One in California, one near Canberra, Australia, and this one in Spain. As Earth spins, that spacing guarantees at least one station is always facing whatever spacecraft NASA needs to talk to at any given hour. Lose one site, even briefly, and there's a real gap in humanity's ability to hear anything past Earth orbit, including the Voyager probes, still whispering back from beyond the solar system after nearly 50 years of flight. NASA pulled all 90 staff off the site as the fire approached. Then came the sentence nobody wanted to read in an official update. The wildfire passed through the complex, not near it, through it. Across ground, where 6 radio dishes have listened to spacecraft since 1964, including one antenna spanning 70 meters, roughly the width of a football pitch, weighing about as much as 7 fully loaded jumbo jets balanced on a single rotating base. When NASA's team returned for a first look on July 25th, the news was about as good as anyone could have hoped for. Damage to the pavement and surrounding scrubland, yes, but no significant structural damage to the antennas or the buildings themselves. The fire reached the hardware. The hardware held. Ship 40 wasn't built to float. Madrid's dishes weren't built to withstand a wildfire that reached their base untouched. 2 survivals nobody predicted, thousands of miles apart, in the same 7 days. Step back and look at everything that just happened in 7 days. A ship that broke its own landing pattern by refusing to sink. A landing precise enough that Musk himself confirmed it would have been caught. A heat shield that survived the hardest ascent SpaceX has ever attempted. A regulator that cleared the next flight without hesitation. A mystery nose cone quietly testing the next generation of payload capacity. A recovery mission about to pull the first surviving Starship out of the ocean. A Mars date backed, for the first time, by hardware that actually exists instead of just a slide in a presentation. Every single one of those threads points toward the same moment, Flight 14, and the first attempt in history to catch a Starship out of the sky. The ship that would have been caught is floating in the ocean right now, waiting to be recovered. The ship that will actually attempt the catch is sitting in a bay at Starbase, one engine test away from finding out if history repeats itself or finally breaks. That's the full picture. Precision, survival, proof against the odds. If this held up, like, share, comment, subscribe to the Space Brief. Tap the screen now. I'm Adrian. Thanks for watching.